All right, let's dive into something that's really flipping the script on artificial intelligence. We're asking this huge question: what if we've got it all wrong? What if the key to truly intelligent AI isn't just about throwing more and more data at it, but about starting with a much smarter design from the get go?
For the longest time, the mantra in AI has been pretty simple. Bigger is always better. More data, more power, that's the only way, right? But what if that's not the whole story? What if there's a more elegant, a much more efficient way to get to real intelligence? That's what we're going to unpack today.
Okay, so first up, let's talk about the reigning champ, the big idea that's dominated AI for years: the myth of big data. I mean, think about all the big names you hear about, right? ChatGPT, DALL-E, all of them. They're all basically built on the same philosophy. More data equals smarter AI. You take a gigantic computer model and you just stuff it with colossal amounts of text and images. Basically, the entire internet. It's a brute force approach, plain and simple. And wow, does this brute force method come with a hefty price tag? We're talking hundreds of millions of dollars for a single model. And the energy, it's like powering thousands of homes. So yeah, it works, kinda, but it is incredibly expensive and honestly super inefficient, which naturally makes you wonder, there's gotta be a better way, right? Well, to find that better way, a lot of researchers are looking at the best computer we know of, our own brain. It's an absolute marvel of efficient design, and it learns with way, way less data. So take a look at how our brains handle vision. It's not just some chaotic mess of neurons firing all at once. Nope. It's this beautiful, structured, step-by-step process. Information moves up a ladder, a hierarchy. So down at the bottom, in a part of the brain called V1, it's just detecting simple stuff, lines, edges, that kind of thing. Then the next layer, V2, starts piecing those together. Then V4 sees more complex shapes. And finally, you get to the IT cortex, and bam, it recognizes a whole object, like a person's face. It's just an incredibly elegant system, building from simple to complex. And this right here, this gets to the absolute heart of the debate. On one side, you have us, humans. Our brains have this smart, pre-built structure that lets us learn super efficiently. A little kid doesn't need to see a billion pictures of a cat to know what a cat is, right? But then you look at today's AI, and it's the total opposite. It needs that brute force flood of data to get to the same place. So how do you actually test this? Well, researchers at Johns Hopkins University set up this really cool experiment. They basically created a showdown between three different AI designs or architectures. Let's meet our contenders. All right, first up, we've got the fully connected network. You can think of this as our brute force baseline. Every single artificial neuron is connected to every other neuron in the next layer. It's this super dense, kind of tangled web. It's powerful, sure, but it's not really specialized for anything in particular, especially not images. Next in the ring is the transformer. Now, this is the architecture behind heavy hitters like ChatGPT. Its superpower is something called an attention mechanism. It basically lets it figure out which parts of the data are most important, no matter where they are. Super flexible for sure, but again, it wasn't really designed from the ground up to understand the layout of an image. And our third contender is the convolutional neural network, or CNN. Now this one is special. Why? Because its design was directly inspired by the biology of our own visual system. It uses these little filters that scan across an image looking for local patterns, and then it builds up its understanding layer by layer. Sound familiar? It's literally mimicking that V1 to IT cortex pathway we were just talking about. Okay, so we have our three contenders. The stage is set for what you could call the blank slate showdown. The big goal here was to see which of these blueprints, straight out of the box, was just inherently more like a brain. And this is where we get to the really mind-blowing idea behind this whole study. See, everybody just assumed that an AI only starts acting like a brain after you train it on tons and tons of data. But the researchers asked a radical question. What if the right design, the right architecture, already has those brain-like patterns baked right in from the very beginning, before it's even seen a single thing? So the setup was so simple, it was brilliant. They took all three of these AI models, and this is the most important part, they were all completely untrained. Just blank slates. Their internal connections were totally random. This was a pure test of their design, nothing else. Then, they showed these random, untrained AIs a bunch of images and compared their internal chatter to actual brain scans from people and monkeys looking at the very same things. So what happened? Well, the results were frankly remarkable, and they really do challenge the very foundation of how we've been building AI for years. I mean, look at this. The results were just unbelievably clear. The fully connected network and the transformer, their random activity showed pretty much zero resemblance to the brain's activity. But the CNN, the untrained random CNN, its activity already looked a lot like the patterns in a biological brain, almost as much as a fully trained model. It was the design itself. That was the secret sauce.
So why? Why did the CNN just blow the others out of the water? Well, it all comes down to its built-in rules, its assumptions about the world. Its design forces it to look at small, local pieces of an image first and then build up a bigger picture in layers, exactly like our brain does. And other smart design choices, like something called pooling, which helps it summarize information, also push it to create these rich, brain-like features right from scratch. The blueprint itself is doing all the heavy lifting. Now, this is way more than just a cool science experiment. This research really points to a whole new future for AI, a future where we build intelligence not just bigger, but smarter, by design. And the real-world benefits here could be massive. I mean, think about it. If AI needs less data and less computing power to learn, it gets cheaper, it uses way less energy. That makes this amazing technology more accessible for everyone, smaller companies, individual researchers. It really democratizes the whole field. And hey, as a bonus, it gives neuroscientists an even better tool for figuring out how our own amazing brains work. The lead researcher, Mick Bonner, put it perfectly. He said the AI field is just obsessed with this idea of throwing more data at the problem. But humans learn to see with so little. And his quote just hits the nail on the head. Evolution may have converged on this design for a good reason. Maybe, just maybe, nature has already figured this out and we should probably start paying attention. So this really leaves us at a crossroads, doesn't it? Is the future of AI going to keep following this brute force path, always demanding bigger data sets and more powerful computers? Or are we about to pivot to a new era of smart, efficient design, learning from the incredible blueprints that evolution has been perfecting for millions of years? This research suggests the answer might have been right in front of us the whole time.